Okay, what does the question say? Determine the what? The what? What's, we gotta read this word? Slope. How many people have heard of the word slope before? Yep, slope has been, I think they start to cover it even sometimes in grade 8, but definitely grade 9 and more in grade 10, and we still revisit in grade 12. Sorry, 11. So determine the slope of each line. Then, once you do that, find the equation of the line, check your solution by using what? How many people have used Desmos before? Raise your, you say what? I actually am so glad to be a teacher because we have Desmos in this day and age. This is honestly one of the best times to be a math teacher or student because honestly, as a teacher, immediately I can prove to you that my solution is correct. And as a student, immediately you can what? You can discover if you did the correct way because you can just sketch it in a nanosecond. Boom. Guess what I had to do in my old days, 23 years ago? We didn't have Desmos. You had to bring a grid paper like this, the grid paper, the graph paper, like this one with the squares, and have a ruler, and make sure you put the tick marks and sketch. Checking your answer took sometimes longer than what? Than actually doing the math to find your answer. Now you literally write it down and it just poofs in colors and you can zoom in, zoom out, do all that stuff. So trust me, when you say you hate it, you have so much at your disposal. You are it's insanely convenient. Okay? All right. First of all, who remembers how we found the slope? I am not expecting anyone to say it perfectly the right way, but I just want to see who would like to volunteer. I guess. Who remembers how we find it? Yes, go ahead. Okay. How many people remember y equals mx plus b? Come on, just raise your hand if you ever remember this weird form, y equals mx plus b. Okay. Y equals mx plus b. Everyone, y equals this thing, y equals mx plus b is technically not the what? It's not the slope, but it includes the what? It includes the slope. This is what we call the what? This is the equation of a straight line. This right here, this famous y equals mx plus b, that is the what? That's the equation of the what? This is our final thing we want to find. The first thing we need to find is this part. We need to find the m. If you find the m, that's like 70% of your solution. Raise your hand if you remember this phrase. Slope is equal to rise over run. There we go. That's what we're going to do today. Rise over run. How do you do a rise over run when you have a graph? You just look at the graph. Okay. So what does rise over run mean? You just have to pick two good points. And by good points, I mean what? 2 points that you can tell perfectly where they are on the grid. Like you're not guessing decimals or fractions or stuff. Okay. So for example, let's actually label all the good points on this line. Let me zoom out so you can see the whole line. Second. Okay. Is this enough? Almost perfect. Yes. Okay. Everyone, where's a good point? That means I need a point that basically falls on the intersection of two of these gray lines. Who can see one of them? Again, I can tell you which points you pick. Yes, Abdullah. So 4, you mean this one? Yes, everyone. Technically, this point right at the very top is a what? Is a good point. So let's circle, not circle it. Let's just what dot it a little bit. Go ahead. So I'm gonna put a small dot on it. Oh, sorry. Dot. Okay. Where's another good point? Hmm. By the way, just so you know, if this is 0 to 2, how much is this? Yeah, 0, 1, 2, 3, 4, 5. And same thing, 0, 1, 2, 3, 4. You always have to know how to read a grid. Okay, everyone, do you think this is a good point? How many people say yes? This, I'm going to label it for you to see. How many people say this is a good point? There are no wrong answers. Okay, so Randa, you were saying, or okay, okay. Who says it's a good point? Come on, raise your hand. Okay, Ibrahim, defend your answer. Why would you say that this is a good point? By the way, if your answer is correct, why is it a good point? Because it falls exactly on the what? On the intersection, on the cross point of 2. Okay, who says it's not a good point? I do. I have a reason to call this not a good point. Can anyone guess why? Yes, technically, Look at where this one falls. Go down, go down, go down. Is this 1 or a half? Everyone, this is 0 and this is -1. What's between 0 and 1? Half. Can we technically still use a half? No. Can you? Can you? Should you? That's my point. Always try to use numbers without fractions. Do you see what I mean? So even though this is a good point, according to the definition of Baram, which is that it's the intersection of two lines, it falls on a fraction. You know what? Let's steer away from that. So let's take it away. Where's another good point? Yes. Where? This one? Yes. Look at this one. Perfect intersection. 1 and -1. Go ahead, label this one. Where's my next good point? Seems to be this one, right? I have a question for you. Look at these, everyone. Mahira, look at these 3 pink dots we sketched. Are they separated exactly by the same distance? Yes. That's how you know you're what? You're getting the good points correctly. Every 2 good points are separated by the what? By different distances or the same distance? Same distance. Look, if you measure the distance from here to here, you're going to find the same from here to here. And if I gave you a longer line, you got to go from here to here, here to here. I can. Yeah. It's from 0 to 31. It's from 0 to 31. If it doesn't matter, look, if math fails, not only I don't have a job, this world doesn't exist. You see what I mean? This every single thing that you built, you are alive right now because of math. Because when you were born and you need some vaccination or some medicine, they would inject you with it, right? Do they just inject you with a random amount of medication? No, they actually have what? Have functions and models and math equations to calculate exactly how much I should inject you with. So by the end of the day, it would wash out of your system without you being what? Like harmed or basically what? Intoxicated. You see what I mean? Math always has an answer. You just have to be patient enough to find it. It's a beautiful thing. Okay, so now what do I do? How many good points did we pick? Guess what? To find the slope, you only need how many good points? 2. So what 2 points could I use? I could use them in any combination. And what? I could use these 2 points. I could use these 2 points. Or I could use what? Yes, exactly. You can use the entire separation. You can use this one and this one. You know why? Because straight lines, everyone listen up. Straight lines are like what? Going up the stairs. When you go up the stairs, do you have to lift your foot more every single step or the same amount? Yeah. I mean, imagine if you're actually going up the stairs and every step you have to lift your foot like an inch higher, an inch higher, an inch higher. These are going to be weird stairs, right? So stairs are steps are always like this. Look, check this out. Here's my first step. And here's my second step. Do these 2 triangles look identical? What do you think? Do they have the same size exactly? Yes, they do. They have to. This length is the same as this one, and this length the same as this one. That's my point. You can use any line, any point. Let's randomly choose, everyone, let's randomly choose this one. Okay, so let's erase this triangle. Or I'm gonna erase it. Oops, my bad. Okay, everyone, I'm gonna erase this. Okay, so go ahead and connect here. Anyone needs rulers? I mean, you don't have to, but some people are. Come on, who needs one? Sure. Two. One. You want? Who else? There you go. Okay, so everyone, we are going to use this one. So go ahead, just sketch a line like this and a line like this. You see, when you're good, you don't need a ruler. Practice makes perfect. Okay, so now let's start with the solution. Okay, Yes. Nope. Nope. Everyone, listen up. Abdullah has an amazing question. He's like, why do I need to use these 2 points? Can't I use these ones which have all positive numbers? You can, but I want you to get used to what? Using things with negative numbers in. Trust me, sometimes I will give you things that are only negative. You're stuck. You have to use these ones. Okay? But here's the good news, everyone. We don't technically need to use what numbers here. I can just look and see how big the what? The base is and the height. By the way, which one is the rise? Which one is the run? Which one is the rise? Which one is the run? Because it depends. The y is the what? Is the rise, and the x is the what? Is the run. So everyone, let's write it down here. M equals rise over run. Okay. How many points, or how much is the rise of this triangle? Well, no, the rise, the rise. How high does it go up? I'll show everyone. Look, I'll show you 2 ways of doing it. You can just count the squares on the grid, or you can do this. Can someone tell me what's this value right here? Right here. Right here. Nope. Not negative. No, not 1. Yes. Everyone, look. What's the height right here? No. Good. -3. Okay. We go up to here. What's the height here? Right here. 1. If you go from -3 to 1, if the temperature right now goes from -3 Celsius to 1 Celsius, how many jumps did it go? How many people say 4? Who said 8? Someone said 8. I just want to count. It's 8 if you count the squares. 1, 2, 3, 4, 5, 6, 7, 8. But we don't have to count the squares. We have to count the full steps. From -3 to -2, that's how many steps? 1, 2, 3, 4. Yep. If you go from -3 to 1, you went up how many steps? 4 steps. 4 steps. So my rise is 4. Go ahead. My rise is 4. Okay. Let's go to the run. Yep. How many? You went this much. You went from here to here. That's what? That's 2 squares, but how many steps? 1 step. Yep. Very good. Come on. How much is 4 divided by 1? 4. Thank you. So the slope of this line is 4. What does that mean? For every 1 step this way, everyone look at me. For every 1 step this way, I moved how many steps up? 4. 1, 4, 1, 4, 1, 4. That's basically what it means. Okay? All right. So what's the equation again of a straight line? The one that Avery said? The famous equation of the line, the equation of the whole line. Y equals. Okay, so let's write it down. Y equals M. Did we just find the M? Did we just find the M? Yes, we did. What's the value of the M? Great. So now I'm going to what? I'm going to improve my equation. So I'm going to write the same, but instead of M, I'm going to write what? Great. You see? You find the information step by step. So this becomes Y equals 4x plus B. What's the other symbol now that I need to find? I already found the M. What's the? No. Okay. Hold on. Everyone, listen up. Everyone. Y and X will always remain as what? Y and X will always remain Y and X. The 2 things that you need to find are the what? The M and the B. M, how do you always find? You 24/7, never changes. How do you find the B? Does anyone remember? You don't have to. If no one remembers, no problem. That's why I review. Who remembers how we find the B? You don't know. You don't need to make a fraction. Anyone remembers? Sure. Sorry, which one? between the 0 and 2. This, oh, no, oh, sorry. This is now -1. My bad. This is not -1. This is just like a dot to tell you the height. My bad. No, no, this is, you know what? How about this? Thank you. Yes, that's only 1. So it looked like a -1. Huh? Does anyone remember how we find the b? Nope. Nope. Sure. Awesome. Listen. Okay, everyone, I'll tell you. It's easier than you think. Look, look. Use any point and sub it back in. Can someone tell me what this point is? No. Everyone, okay, good review. Whenever I ask you what is a point, you have to give me the x location and the y location. A point is 2 numbers. X location, y location. Can someone tell me, sorry, what's the x location of this point and what's the y location of this point? Yeah, so basically you have to give me something, comma, something. How many people agree with Qasim that the x location is 0? Okay, I'm hearing some people saying 0, 4, and some people saying what? 4, 0. How many people say it's 0, 4? How many people say it's 0, 4? What's up? Oh, sorry. It's, yeah, you're right. It's actually not 4. It's 2, 3, 4, 5. So how many people say it's 0, 5? Okay, how many people say it's 5, 0? No, just like the alphabet. X, Y, Z. X first, X value first, and Y value second. Where is the X value here? You're right here. You did not move sideways. So you're still at 0. But how much did you move up? There you go. It's 0, 5. Yep. Good. Okay. Can someone tell me the location of this point? This one. The big dot. Okay. Again, I'm loving that people are participating, but just to give everyone a chance, always just raise your hand first. Okay. Moment. What's the location of this point? X. Okay, you got one of them right because it has a height of 1. But how about this? Oh, sorry, I'm looking at you're right. -1 and what? So -1 and 1. You see? Yes. So everyone, go ahead. -1 and 1. Okay. Last point. Who would like to give me the location of this point? Okay, Abdullah. The X is nice. Is it? Oh, there's no over. I just need 2 numbers. Okay, Ryan. It's the opposite. Yeah, look. It's here, right? You have to move this way first and then this way second. By the way, always move on the X first. How did you move here? Did you move left or right? Sorry, right or left? You move left. To what point? -2. And then what did you go? Up or down? How many? There you go. -2, -3. So how many good points do we have? 3 good points. We can use any of them and sub them in here. Okay. Let me show you what I mean. Oh, okay, let me show you what I mean. Okay, everyone. Which point should we use? By the way, whatever point you use, you're going to get the exact same answer. All of us will have the exact same final answer. How many people want to use 0 and 5? How many people you want to use -1 and 1? How many people want to use -2 and -3? Okay, seems that -1 and 1 got the most votes. Great, let's use -1 and 1. Okay, so I want you to write this now. Oh, sorry, right here. Okay, so let's say this. Let's use -1 and 1. By the way, which one is the x value and which one is the y value? X is the -1 and y is this. How do you use it? Nothing. You write this equation, everyone. You write this equation. I'm actually going to put it in highlighter to tell you that this is the one we're going to use now. So it's this equation. And the x we're going to replace with what? -1. And the y will replace with what? With 1. Okay? Let's do this. So it becomes what? Yeah, no. Yeah, you don't need to call it y. You already have a value. 1 equals, yes, 1 equals 4. Nice, bracket. Don't put the x, put the bracket. Get used to bracket with multiplication. -1 plus what? And now we have to solve for the b. How do I clean this up first? Obviously, I have to multiply 4 times -1. What's 4 times -1? 4 times -1, -4. So this becomes 1 equals -4 plus b. I'm just going to make the bracket smaller. Okay. How do you solve that for the b? Do you move the b or do you keep it where it is? By the way, how many people would like to move the b to the left side? Because they always say that the variable should be on the left side. You can, but there's one slight complication with that. I mean, you 100% get full marks. If I move the b here, the plus turns into a what? So I won something, but I lost something. I won that what? That b is on the left side, but now my b is what? Negative. It's okay. Keep it where it is. So yes, we move the what? The -4. You move the -4 to the other side. So I'm going to circle it and move it. What does it become? 4 plus equals. So now we can say what? B equals what? Oh, Rawan, it was already -4. When you cross the equal sign, the minus turns into a what? No, the minus turns into a positive. You don't have to show it though. So what's my final answer? No, what's my final answer in the whole thing? Y equals no, 4. You see? Two things you had to find. The M, the M and the B. So your final answer is this. Y equals 4x plus 5. And please always, by the way, whenever you get to a final answer, always put it in a what? Put it in a small circle or a box. Okay? Just to tell me I am done. This is my final answer. Okay, everyone. How did it tell you to check? Use this. Okay, everyone. Here's Desmos. Check this out. What did we say the equation was? Y equals what? They're the same one. 100%. It goes through 0, 5. It goes through 0, 5. It goes through this one. It goes through this one. Sorry, yeah, right here. It's exactly the same thing. Whenever you do math, Desmos, you have it. It's free. You can use it as a desktop thing or as an app. Stop complaining. Okay? All right. Next one. Come on. Same idea. Okay. How many good points can you see? Just 2? Okay. Where's definitely a very good point? Right where? Right here. Okay, go ahead. Label. Oh, might as well get the coordinates or the location. What's the location of this point? Come on. Yes, -2 and 2. Okay, I just need one more point. That's all I need. Yes, right here. 0, because you didn't move sideways, and you went straight down. 0 and -3. Where's my triangle? Raise your hand if you can see the triangle. I can see it. It's right here. This guy. Go ahead, sketch it. There we go. Okay, let's start with the solution. What do I always find first? The M or the B? You can never find the B first. You have to find the M. Okay, so M equals rise over run equals. Okay, hold on 1 second, everyone. Is this line, everyone, is this line going up or going down? And you have to prove to me why you chose one answer. Is this line on the rise or on the decline? Okay, how many people say this line is going up? Hold on. Let's just take a vote. You're saying, okay, so who's saying it's going down? Who's saying it's going up? Okay. Abdullah, why do you say it's going up? Prove to me why you think it's going up. By the way, he's not fully incorrect, but go ahead. Oh, so you're saying it's going from a low height to a high height. Okay. How many people say it's going down? Rowan, why do you say it's going down? Listen up, everyone. Go. Like, why would you explain to a younger sibling that this is going down, not going up? I'm teaching. Because everyone, an important thing in math is that we have to agree on a what? On a direction of what? Of moving. Which way does any line go? From the left side of the screen to the right side of the screen, or from the right side of the screen to the left side of the screen? You always start, just like English. You all start from which side? Left, and you make your way where? To the right. If we do that, then how is this line going? Is it going this way or this way? No. It's going that way, right? So it's going from where? From top to what? So is this line going up or going down? See, that's the thing about math. You cannot just say, well, I want to move this way. You never move on the grid this way. The grid does not go from the right to the left. It goes from where? From the left to the right. Also, another question, everyone. I'm pretty sure you remember this. If you're going to label your axis, where do you put the Y? Do you put it down or above? When you put the symbol for Y, where does it always go? It goes on top. Where does the symbol for X go? On this side, on this side, on this side. What does that mean? You're always going that way. Okay, so always remember, you're always sliding on any curve or line from where? From which side? From left to right. Always from left to right. So going to this one, this line is going down. When you're going down, does it really have a rise or a drop? Is this line going up or going down? A line that's going down, does it have a positive slope or a negative slope? Because it's not really rise, it's actually what? Is it rising or dropping? Sadly, the equation now does not say drop over run. You will never hear a math teacher say the equation for slope. Listen carefully. You will never hear a math teacher say the equation for slope is either rise over run or drop over run. They always call it what? They always call it what? Rise over run. But your rise could be positive or it could be what? Negative. If it's going up, it's a positive rise. If it's going down, it's a what? It's a negative. So you have to put the negative now. Now you have to put the what? The negative. So let's see how many units does it drop down by. Okay, let's just look and see. How much did it drop down by? Yes? How many people agree with Qasim that it's 5? Let's count. Let's count. Apparently, each 2 squares is a 1. So 1, 2, 3, 4. Great. But is it 5 or negative 5? Yes, it's a drop. Nice. So hold on 1 second. Negative 5. Okay, hold on. How many did you move this way? 1, 2. Just so you know, everyone, your rise could be positive or negative, but your run is always what? Positive, because you're always running which way? Left or right? You're always running this way. You always run to the positive, but you could be rising or dropping. So always remember, your run is always positive. So what would this be? 2. Ooh, 5 over 2. Can you simplify? Can you simplify 5 over 2? Simplify. Or are you stuck with 5 over 2? But does it lead? By the way, I am not a big fan of decimals all the time, but do you think this leads to a good decimal? Yes, Momin, what's up? Uh, complete. Okay, just so you know, this one could be positive or, but this one always has to be what? Positive. Always remember it that way. Okay. Can someone tell me what's the decimal that comes out of 5/2? Like if you divide $5 by two people and you want to keep nothing to yourself, how much do you have to give? 2.5. Yes. Everyone, go ahead. Let's use decimals today. It's okay. Go ahead. Negative 2.5. All right. What was our next step? Come on. We found the M. We need to find the B. How did we find the B? We chose a what? We chose one of the what? One of the. How many people want to use the point negative 2, 2? How many people want to use 0 and -3? You know what? I'll add my vote to that one. Everyone, I have an advice. Piece of advice. Whenever you have a point with a what in it, use it. Because 0 is the what? It's the easiest number, right? So whenever you have a point with a 0, use it. Again, how can you check? You're going to use what? You have to get the same answer. So let's use what? 0 minus 3. So go ahead. Y equals mx plus b becomes what? Y equals what? What does the m become? What? Yep, the m became negative 2.5. So negative 2.5 x plus the unknown b. Okay, we said let's use what was it? 0 minus 3. Which one is the x? Which one is the y? Yeah, just like the alphabet. X comes first, y is second. So this one becomes x. This one becomes y. Okay. Everyone, let me just give me a second. Let me just squeeze this so it doesn't occupy this much space. Perfect. Okay. What does the y become? (2.5) times what? 0 goes where the x is. Come on. What's 0 times any number? 0 times any number, no matter how big, how small, how positive, how negative, 0 times anything is 0. You see why I use the 0? Because it's going to make my life simple with the math. So negative 3 equals 0 plus b. Come on, what's 0 plus b? What's 0 plus anything? If you add 0 to anything, does that anything change or stay the same? Stays the same. So what's my final answer here? B. So what's my final answer? Y equals 2.5x plus. Okay, hold on. Can you say plus -3? No. Can you? But when you have a plus with a minus, which one wins? Minus. Full marks. Check with Desmos. You will find it's gonna be the exact same thing as this one. Point for point. Yeah. You see, in math, every step has a meaning and has a reason we do it for. There's no need to think that, well, the teacher does it this way. I have no idea why they do it this way. Now you understand why. Okay? We're good? I'm not going to bother with using Desmos because of 2 reasons. We've already done it, and you know it's going to work. But please always check for yourself whenever you do your own calculation. Okay, everyone. Next question. Quite straightforward and easy. What does it say? What's the first word? Evaluate. What did evaluate mean yesterday? Find the value. Now, this is what? some equation. By the way, just so you know, if you're interested, this is the equation that tells you. Does anyone know what capital V stands for in math? Well, we're gonna do a whole unit on geometry. Who knows what capital V stands for in math? Say again. Volume. Capital V is volume. What's capital A? Area. SA is surface area for a 3D shape, like this binder, for example. What does L stands for? Length. How about P? Perimeter, which is the length around all that stuff. This is the volume of a cylinder. Who knows what a cylinder is? What's a cylinder? What's another name for cylinders? Come on. Technically, is this a cylinder? Sorry. Does this look like a cylinder? Kinda. Yes, but a cylinder should be what? Should have the exact same what? Should have the exact same area going up. This is wider here than here. What's another name for cylinders? Come on. What looks like a cylinder? A perfect cylinder. What looks like this? What always looks like this? Come on. Give me other names for cylinders. Starts with P. You'll find it in the ceiling. Come on. The pipe. Pipe. What's another name for a pipe? Starts with a T. Tube. Do you see what I mean? Words mean the same thing. They're just fancy that way. What's up? Ben? Yeah, go ahead. I don't think I have any on that. I don't think I have. Yep, sorry. Okay. All right. So this is the volume of a pipe. Am I giving you values to plug in? Come on. Am I giving you values to plug in? Yes. What am I telling you for the radius? How much? How much for the height? What's this weird symbol? Pi. Who knows the symbol? The value for pi? By the way, pi is an infinite number. It never stops. 3.14 right there on 3.14. So let's go ahead. Let's just plug in. V equals. Go ahead. V equals 3.14 bracket. What's my radius? 2.5. Oh, okay. The old Samsonite. Square. What do I do? Nothing. I have to do BIDMAS though. What do I need to do first? Which one? Which part? Left part, right part, or the middle part? Seems to be the middle part because it's exponent. Okay, let's do this. Here it is. So go ahead. 2.5. 2.5 squared times what? Yeah, it doesn't matter which one you multiply first. I'll multiply this one first and then this one. Times 3.14 times, what was it? 4.8. Now, I'm asking you to round it to how many decimals? What's up? Yeah, go ahead. Where do I get from? Oh, 3.14 is one of the most important numbers of this universe. Anytime you use a circle, you have to use what symbol? Pi. And pi is always what? 3.14. Always remember it that way. Okay? Never. It's a constant. This whole universe is built on the fact that pi is equal to what? 3. By the way, just so you know, everyone, look. Let me just write this down first, because I want to do two things with it. Look, 94.2. Just go ahead, write this down, and pencils down. By the way, if you want to know a little bit, just a small part of this value for pi, here it is. Where's the sim? Where is it? Do you see it? By the way, just so you know, it never ends. Pi is an infinite number, never repeats. They always thought there is this block in pi, like there is this part in pi, maybe from here to here, that repeats, which means if we know that block, we can just hit copy paste, copy paste, copy paste, copy paste. They actually proved mathematically that there is no way, there's no part of pi that perfectly repeats. By the way, there are competitions for people to memorize pi. Obviously, you can never memorize pi because pi is a what number? Infinite number. But so far, I think, listen up, so far, I think the record for someone who memorized the digits of pi, I think someone memorized up to 10,000 digits of it. Yeah. Those are people with a very interesting brain chemistry, and and they train. No, those memory exercises. They're just doing that all the time. Those are the people who memorize phone books. Great, but it shows you how amazing the brain is. 10,000 digits. By the way, I built a career as a math teacher. I only remember 5. 3.14159. Done. 14159. And I have a math and physics degree out of it. You see? Even if you know it as 3.14, that's more than enough. Yes. Go ahead. So, what's the answer, everyone? What was the answer? Okay, 2 things. Listen up. No, hold on. I am telling you, round your final answer to what? How many decimal places do you see now? Like how many digits am I showing after the dot? But I'm asking you to show what? But the number already came out to just what? When you have to add more numbers to a decimal to satisfy the question, what's the only digit you add? 0. Go ahead, add a 0. Okay. Now another thing. Do you know how we measure volume? If I ask you right now, moment, how long is this pencil? Go ahead, hold it. What do you just do? Everyone look. You just put it against the ruler. Go ahead. And you measure it. How long? Everyone listen up. Moment, roughly. How long is this pencil in centimeters? 15 centimeters. Okay. So we understand that when you measure length, you just measure it with what the units? Give me units of length. Centimeters, inches, meters, big ones, kilometers. What about in the States? In the States, they use miles and so on and so forth. How about if you want to find area? What if someone says, we want to what? We want to paint this floor. I need to know how big the floor is. You can't just say, oh, the floor is 15 meters. So, but what's the unit? What's the unit of area? No, you can use centimeters, but you have to say it differently. Centimeters squared. Area is always what? When you rent an apartment, what do you always ask for? The square footage. The square footage. How about volume? Come on, think. One of them was centimeters. The other one was centimeters squared. What's higher than centimeters squared? Centimeters cubed. When you fill when you fill a car or a motorbike with gas, what do you always What do you always say? How many people have seen this? How many people have seen this? When you talk about like a motorbike, you always say, "Oh, what's the gas tank capacity?" They all tell you, "Oh, it's 150 cc." Who knows what cc means? Come on. Cubic centimeters. The amount of gas that could go in the tank is what? Is a volume. So it's what? Cubic. That's what cc means. Whenever you talk about motorbikes, gas tanks are what? Cc, cubic centimeters. So what does that mean? If you leave your answer like this, do you get full marks? No, you don't. You're forgetting the units. Everything in math has units. If I ask you right now how tall you are, and you say, oh, I'm 175, I'm like, 175 what? I mean, I understand it's 175 what? Centimeter. No, centimeter. You see? What if you were 175 inches? You're like 10 Mr. Louse together. You see what I mean? You have to put units. So what's the unit for volume? We said what? Centimeters. But to what power? Because volume is 3-dimensional. Volume is 3-dimensional. All right? We're good? Come on. How about this one? Another volume. Would anyone like to guess what volume is this for? I'll give you a hint. There's a pie. So it has to do with a circle. But a circle is 2D. What's a 3D circle? A sphere or a ball. Yes. Everyone, this is the volume of a what? Of a ball. Okay. What's the only variable I need? Come on. Radius. What's the radius? Great. Let's do it. Come on. V equals 4/3 times. Come on. What's the value of pi? Two digits. 3.14. Please don't remember more than that. You're not going to understand math anymore if you remember more. Times 2.5 cubic. All right. By the way, can we replace 4.4? Sorry, can we replace 4/3 by a decimal? What do you think? Yeah, I think. I mean, I'm already using decimals. So what's another decimal? What's 4/3 as a decimal? Oh, it's an infinite decimal. Look, it's 1.3333 forever. Never ends. How many digits should we take? Oh, let's take 2, because I'm already asking you to put your final answer in 2 anyway. So go ahead and put 1.33 times 3.14 times 2.5 cubed. Sorry, say again. Are you giving me the final answer or what? As what? Sorry, which part? Yeah, you can just put 1.33 and stop there. No, everyone, listen. Rawan is saying, can I just put 1.30? Not quite. You have to stop here. So you have to be what? You have to keep the last number or last digit. Okay? All right. So what's the final answer here? Let's calculate. So 1.33, sorry, 1.33. 1.33 times what? 3.14 times, I'm going to open a bracket, put 2.5 in it, cube it, and close the bracket. Boom, that's my final answer. But I only want to keep 2 decimals. What's my final answer? 62.25. Sorry, 65 point. I mean, 65 point what? 25. Again, is this a volume question? Yes. Again, what's the unit of volume in this question? Centimeters cube, or you can say cubic centimeters. It doesn't matter which way you say it. Nice. Okay. Can we go solve it? Yeah, sure. Okay, everyone. Out of the next 2, because we only have 10 minutes, about 10 minutes, I'm just going to do one, assign the other one as homework. I'm going to do the second one. Because the second one will end up being tougher than the first. So I'm going to assign you the easy one as homework. Okay. Okay, everyone. Pencils down, please. Phones away. Focus on this question. It's easy. You just have to understand what it's asking for. For each table of values, calculate the what? I'll explain what that means. Why? Determine, once you calculate these, if the values represent what? Who can read this word? A linear, a straight line. Should you put the points on the grid? Or a what? Who can read this word? Quadratic. Guess what? We're going to do an entire 2 weeks on quadratics towards the end of the course. But it's good just to understand this today. So by doing this, you're going to be able to tell what? If it's a what? Or a what? Quadratic. Check your answer by what? Sketching the points on the what? On the grid. So I'm not asking you to sketch first and then tell me. I'm asking you to do what first? Differences. Then tell me if it's what? And then what? Sketch to see if you got the correct one chosen. Okay? How do we find those differences? Okay, everyone? Look at this. Again, I'm not going to do this one. I'm going to do this one. So let's do this one together. Come on. I didn't even need to look at the grid. I'm just going to look at the table. Okay, everyone. First of all, I want you to check one thing for me. What's this value? Oh, sorry, what's this character right here? X. So this is the column for x's. Everyone, eyes on here. What's my first value? -3. Okay. Are the x's going up exactly the same amount every time? Again, forget the y's. Are these increasing the same amount? Yeah. And how many steps each time? 1 step. I'm going from the left to the right, right? Make sense? Okay. You check that, and then you go to the second column. What's my first value? How do you calculate the first differences? You subtract, because it's differences. Difference means subtract. You subtract this guy minus this guy. All right, let's write it down. 10 minus what? What do you get? All right, that's good. Keep going. What's my next one? 12 minus 10. Yeah, you're right. Did I get the same answer or a different one? No. Did I get the same number? I mean, if you do not get the same number, boom, it's not a line. You know at least it's not a line. What is it? I'm not sure, but I know it's not a what? It's not linear. Thank you. Keep going. What's my next one? Not quite. It's not the slope. Not quite. What's my next one? 15 subtract 12. How much? That's the whole idea. Keep going. Keep going. 19 minus 15. How much? Last one. Okay. Now, did I get the same numbers? If you don't get the same numbers, what do? You do the same thing, one more step. So now what am I going to subtract? 2 minus, nice, right here. 2 minus 1. What's 2 minus 1? What's 3 minus 2? No. 1. 4 minus 3. It's not coincidence. I made the points that way. What's the last one? Are my second differences the same? Are those ones the same? Boom. If the second ones work out, everyone, let's highlight these, or you can box them or circle them. If they come out to be the same, it's a quadratic. Does anyone know what's the name of a quadratic curve? It starts with a P. I know if anyone remembers it. How many people remember the name or the word parabola or parabola? Yes. If I sketch this curve, it will go as a parabola. Oh, by the way, I'm not sure if it's going to go up or go what? Could be open up or open down. Okay? But I want you basically now to say what here? What's the decision? Is it a line or a quadratic? What did we say? No. It took 2 steps to get them correct. Sorry, it took 2 steps to get them to be the same. If it took 1 step, it's a what? If it took 2 steps, it's a what? No. It's a, what's the other word? If it took 1 step, you got it. If it took 2 steps, you got it. Question for you. What if it took 3 steps? What's after a quadratic? Starts with a C. Cubic. Do you see what I mean? It gets more and more complicated the more steps you have to take. That's it. So the decision was what? Oh, I thought I had the word decision. Oh, yes. Oh, I don't have it here. My bad. So what's the decision? Quadratic. Whoa. Sorry. There we go. Quadratic. How can I check? What did I tell you to do to check? Come on. Sketch. Okay, everyone? Let's sketch those points. Okay, I need someone's help now. I'm going to look at this, and I'm going to just put the points on. Okay. Yeah, tell me the x value and the y value. Okay. What's my first x value? Come on. Hold on. Do I need to change the layout? So yeah, I need to. It's just a small thing. You do the Microsoft Word is weird this way. I have to make layout up. Now we're good. Okay. Let me zoom out a little bit. Okay. Go ahead. What's my first? Oops. My first point is -3. Thank you. 1 second. Okay. You said -3. And what's my height? 9. So where's 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here. Go ahead. Okay, what's my next point? -2. And what point? Point means 2 values, an x and a y. X is -2. What's y? 10. Interesting. So I'm going to go -2 and 10. Right here. Keep going. What about -1? How high is it? 12? Okay. 12. How about 0? 15? Thank you. 15. Who sees it? Who sees the curve? Yeah, it's curving. Keep going. 1. How high is 1? 19, right below the 20. Last one, I think. 2, 24. 20, by the way, 25 is here, not here. 25 is here. So 24 is right here. And what do I do with these points now? I have to what? I have to connect. Do you ever connect them as like this? No, you never do a bunch of broken lines. You have to make it a smooth what? A smooth What do you call, what's the opposite of a line? Starts with a C. Curve. You have to make it a smooth curve. You're not going to lose marks if it's not super smooth, but it needs to be a curve. Everyone look. You start roughly from here, and you try. Do you know what we put at the end of the curve on each side? Come on, to say that the curve never ends. Yes. You put two arrow heads right here to tell me that it never stops going this way, and it never stops going this way. Guess what? It's a quadratic. It did curve. Okay, since we have time, let's do the next one. Come on. It's so easy. Okay. What about this one? Come on. What's 7 minus 12? Go. 7 minus 12. 7 minus 12. 5 minus. 2 minus 7. Interesting. Negative 3, negative 2. Negative 8, negative 3. Watch out. This is where, yeah, no. Negative, what's negative? So what's negative 8, positive 3, negative 5 as well. I worked out the values this way. And what's negative 13? Negative 8. Another what? Another. By the way, never assume that because the first few worked, that everything else will be the same. I could screw up the last value. I could make this one negative what, for example? I could make it negative 14. You would get what then? Negative 5, negative 5, negative 5, negative 5, negative 6. If you didn't do the last one, you would think it's a line. I might. By the way, I could screw up one of the values. Usually it's the last one because I want to see who does the whole thing and who assumes, oh, it's got to be the same. You do not guarantee until you get the whole thing. Did we get the same answer every time? Great. Is it a quadratic or one step less? It's one step less. It's a what? It's a linear. And guess what? If you plot it, if you put the points, you will actually see that it works out. I'll leave that as homework. Done. That's today's lesson. You see, math makes sense. You just have to say it the right way.